Hey everybody, we're back and we're learning about completing the square or how to complete the square. So section 1.7, how to complete the square. Our learning goal today is students will be able to solve the quadratic equations by completing the square. So that's a process that we're going to learn today. And I want to remind you, so just kind of wake up the part of your brain. So we're just going to remember that solving or simplifying using square roots can be pretty easy. So remember, if I've got x minus 2 all squared, I want to get x by itself. And I'm going to take the square root of both sides. But remember, when we take the square root, it's plus or minus. A square root cancels out the square. We're left with x minus 2 equals plus or minus the root of 16, which is 4. And when I get x by itself, we're going to add 2 to both sides. So we're left with x equals 2 plus or minus 4, which can be written as 2 plus 4 and 2 minus 4. So that's 6 and negative 2. Okay? Also, remember this little negative information. You may have learned that in Algebra 1, that the root of negative 1 is I. Remember, I stands for the imaginary number. So up until a certain point, you always learned no roots of a negative. Well, when we want to solve something in the imaginary realm, we say that the root of negative 1 is I. So for example, if I said, what's the root of negative 4? I'm going to split this up, and I'm going to say this is the root of 4 times I, which is just 2I. Because whenever we have that root of a negative, that turns into an I. Same thing here. The root of negative 16 can be written as the root of 16I, which is really 4I. So hopefully that sounds familiar. Just wanted to wake up that part of your brain. We're going to be using some of this today. Okay, so let's just go ahead and jump right in. What if they asked us to solve x squared minus 8x plus 16 equals 25. Now, up until this point, we've always said if you're solving, you set it equal to 0. But this one is really special because if you look here, this is what's called a perfect square trinomial. And it's a trinomial because there's 1, 2, 3 parts. And this term right here is a perfect square, where the root of 16 is 4, and this number here is double the 4. So when it has this pattern of there's a root here, and the root doubled is this middle term, that's what's called a perfect square trinomial. So what happens is, when we have a perfect square trinomial, when we factor a perfect square trinomial, we're going to go like this. It becomes a perfect square, where we know x squared is really made up of x times itself, and we know the root of 16 is really 4, and we take the sign that's right here, so we put a minus. So we know x minus 4 squared is the same as x squared minus 8x plus 16. If we were to FOIL that out, that's what we would get, and then we're going to bring down the equals 25. Now this looks a lot like what we were doing up above, where we take the square root of both sides, plus or minus. This cancels out the root and the 2, the squared. So we get x minus 4 equals plus or minus 5. When we add the 4 to both sides, we get x equals 4 plus or minus 5, which is really 4 plus 5 is 9, and 4 minus 5 is negative 1. And those are our solutions for x. So again, this is if you have a perfect square trinomial, which is perfectly factored as this nice little parentheses squared. So we're going to explore that a little bit more. So here's what we're looking at. Here's our key concept of how to complete the square. So in words, to complete the square for the expression x squared plus bx, to make it a perfect square, we take half of b and we square it. So to show you in a visual format, in the diagram, if we look at an area, because we know an area is a square, right? It can be a square. Instead of creating this area as a rectangle, they took half of this piece right here. They took half of it and they moved it here. So which basically leaves us this kind of like zigzaggy shape. And to make it a complete square, they took half of that B and they squared it right here. Okay? So I'm going to clean it up a little bit. So by algebra, when we're talking about the algebra, here's what we're talking about. If we've got x squared plus b squared, we know that half of b squared will make it so that we can factor these to x plus the b value over 2 times another x plus the b value over 2 equals, and then those two identical parentheses is just the same thing, and then we can put a squared on it because they're identical. So here's how we're going to use it. We're going to make a perfect square trinomial, or perfect square trinomial, where we can perfectly square it, where we find the value of c that makes x squared plus 16x plus some value of c a perfect square trinomial. Okay, so when we look at this, we know that value of c is b over 2 squared. So in this case, we know our a value is 1, we get it right here, and our b value is 16. We don't have a c value yet, we're not sure what that is. So to make it a perfect square trinomial, we're going to take the value of b, which is 16, and divide it by 2 and square it to find that value of c. So 16 over 2 is really 8. Square it, and we get that 64. So the value of c is 64 to make it a perfect square trinomial. So your turn. You're going to find a value of c that makes a perfect square trinomial for this right here. So we're going to look for that value of c that would make it a perfect square trinomial. So we know c equals the b value over 2 squared. So let's look at for your a and b. How do you find c? C equals 14 over 2 squared, which is really 7 squared. So hopefully, whoops, you got 49. Here we go. So, what if they asked you to solve a squared plus bx plus c equals 0? So this is the form that we're talking about when the a value equals 1. So that's a specific system, or a type of solution. So we've got x squared minus 12x plus 4, where the a value is 1, by completing the square. So here are the steps of how to actually complete the square. If the a value is 1, our first step is we're going to move the constant term, or the number over. So with this minus 4 on both sides to get that to go away. So we've got x squared minus 12 equals negative 4. And then step 2 is we're going to rewrite it with spaces. So we're putting those spaces in right here. After this, whoops, I forgot to write the x down. Here's our x value from up here. We're going to put a space there and a space there on both sides of the equal sign. Step 3, we're going to fill the spaces with b over 2 squared, which this is our completing the square step. So we go b over 2 squared. So let's find that. Our b value is right here. So it's negative 12 over 2 squared, which makes it negative 6 squared, which is 36. So we put a positive 36 here, and we also put it here because when I add something to one side of the equal sign, I have to balance it. And so in this case, the other space, we're going to add the same thing so we can balance both sides of the equal sign. Step 4 is we're going to factor the first three terms so that we have that perfect square. Okay, so here we go. We're going to make our perfect square. So we know x squared is really x squared. And whatever that number was before we squared it, that is what's going to go right here. And then we're going to simplify the other side of the equal sign. -4 plus 36 is 32. So that's our beautiful completing the square. It looks pretty. It's like a cute little birthday package, right? And then step 5 is now we're going to solve what we have. So here we go. We know if we're going to solve x minus 6 squared equals 32, we're going to take the square root of both sides. When we take the square root, it's always plus or minus. These will cancel. X minus 6 equals plus or minus root of 32. This isn't quite simplified, so we're going to pull a 16 out of 32 because I know the root of 16 is going to be 4. So we have plus or minus 4 times the root of 2, so now that's simplified, equals x minus 6. Solve for x by adding 6 to both sides. We've got x equals 6 plus or minus 4 the root of 2. And now we're going to write this as, you can either leave it like this, or you can write it x equals 6 plus 4 root 2, comma, 6 minus 4 the root of 2. And that's as simple as it gets. You can write it either way. I don't care. But there are two separate solutions for that. So here's your turn. You're going to do solve by completing this square. So I'm going to follow those steps. I'm going to write them out for you, and then you're going to put one of the steps as an answer. So here we go. Remember, the first step is we're going to move the constant term or the number over to the other side. So we're going to move the 4 over. X squared plus 6 equals -4. Step 2, do you remember? Rewrite it with spaces, yes. So now our spaces go here and here. Step 3, we're going to fill the spaces. Now this is the most important steps. Fill the spaces with what? B over 2 squared. I hope you got it. So B over 2 squared is going to, here's our B value. So we put 6 over 2 squared, which is 3 squared, which is 9. So that's what we're going to put here and here is both positive 9. And then our next step 4 is we're going to do our perfect square step. Okay, so we're going to factor to get our perfect square step. So we know x times itself is x squared, and whatever before we squared it goes here. So if it was positive 3 there, it goes positive 3 here. And we just simplify the other side. -4 plus 9 is 5. And step 5, we're going to solve. So here, now to solve this, we're just going to take the square root of both sides, plus and minus. These cancel. We've got x plus 3 equals plus or minus the root of 5 minus the 3. We get x equals -3 plus or minus the root of 5. And now you're done. Hope you got that on your turn. Now, we're going to complete the square when a does not equal 1. So this is just like what we were doing before with one added step, when our a value does not equal 1. So when our a value does not equal 1, we've got one extra step, and it's right here. And we're going to divide each part by a. So here's a. We're literally just going to divide every single part of the equation by 2. Okay, because we're doing it on both sides of the equation, it's legal. It keeps the value of our original equation. This cancels, and we've got x squared plus 4x plus 7 equals 0. Now we have that a value of 1. So now we can complete the square with the same steps that we had before, where we move the constant term over. So we're going to move the 7 over to the other side. So we've got x squared plus 4x equals -7. Our step 2 is we're going to rewrite it with spaces, right, to balance the equation. So we're going to put a space here, and we're going to balance it on the other side of the equation right there. And then step 3, we're going to fill each space by b over 2 squared in both of the spaces. So b over 2 squared is really 4 over 2 squared, which is 2 squared, which is 4. So we're going to add 4 in both spaces. Step 4, we're going to do our perfect square step. So now we're factoring that step into our perfect square step. So here we go, perfect square. We know x times itself. We get back x times itself, we get back to x squared. And then we go plus whatever we put before we squared it goes right here. And then we simplify the other side of the equal sign, which is -3. And then the last thing is we're going to solve. So in order to solve this, we're going to take the square root of both sides, plus or minus. We're left with x plus 2 equals, now remember, the root of negatives is an I, and that's a root of 3, minus the 2 to both sides, and we're left with x equals -2 plus or minus the root of 3i. Don't let the I freak you out. It's just a number. We keep it on the end. Okay? All right, let's look at this one. Let's say we've got this figure, and they know the area. The area is 72 units squared. What's the value of x? Well, the dimensions of the rectangle are 3x and x plus 2. So we know the area equals length times width. Remember that from way back when? So 72 is the area equals the length, which is 3x, and the width is x plus 2. So we're going to use completing the square actually to solve for x. So we're going to distribute here, and we've got 72 equals really 3x squared plus 6x. Now we're going to use completing the square. Okay, let's look at this. I'm going to move the 72 over to the other side just so that it looks like what we've been using. Okay, so it looks familiar to you. Remember, we're going to look at our a value first. And if a is not 1, if a is bigger than 1, we're going to divide both sides by a. So we're going to divide everything by 3. And we get x squared plus 2x equals 72 over 3 is just 24. Now we can do our completing the square steps. Number 1, we're going to bring the constant to the other side, which we did already. It happened to be already there. Step 2 is you're going to rewrite it with spaces, right? So we're going to put our spaces here after the x and on the other side of the equal sign here. Step 3, we're going to fill both spaces with b over 2 squared, which is our complete the square step. 2 over 2 squared is really 1 squared, which is 1. So we're adding 1 to both sides. And step 4 is we're going to do our perfect square. So here we go. Here's our perfect square. We know x squared is just x squared, right? And if whatever I had here before I squared it goes inside right here, which is a positive 1, so we write plus 1. And now we're going to simplify the other side, which is 25. Last step, we're going to solve. And we're going to square root both sides. Cancels, we get x plus 1 equals plus or minus 5. Subtract both sides of 1. We get -1 plus 5 is 4. And negative 5 minus 1 is negative 6. And our last one, we're going to write this in vertex form. This is our last example. So remember, vertex form was y equals a times x minus h squared plus k, right? So if we're looking at that, doesn't that look like a perfect square, right? This looks like this really nice perfect square. So we're going to use completing the square to solve for this, okay? So just like before, but except for this time, we've got y that has to stay by itself. So we're gonna do a little bit of a variation on this, but it's the same idea. So same thing, number 1, we're gonna look to see what our value of a is. It's 1, so we're good. Step 1, we're going to move, normally we'd say move the constant over, but in this case, we're not gonna move the constant over because we want 1, or the y, to be on this side. So we don't have to do step 1. Step 2, we're going to rewrite it with spaces because we want it to look like this. So we're going to say x squared minus 10x, but our spaces is going to be after the x like it was before, plus the 22, and then we're going to put another space behind the 22, but instead of adding in both of these spaces, we're going to add in the first one and subtract the second one. And that's because both spaces are on the same side of the equal sign. So if they're on the same side of the equal sign, to keep it balanced, we add it and then we subtract it on the same side. Step 3, we're going to fill the spaces with the completing the square step of b over 2 squared. Okay? And here we go, b over 2 squared is going to be negative 10 over 2 squared, which is negative 5 squared, which is 25. So we're adding 25 here, and we're subtracting 25 from the same side to keep it on each side, even on the equal side. Okay, on the both sides of the equal. So step 4, we're going to make our perfect square. So our first 3 terms are going to be a perfect square, just like before. X squared is x squared, and we know whatever we squared is going to go right here. We squared that minus 5. We simplify what's left, which in this case happens to be on the same side of the equal sign now. So this is a minus 3, and now we're done. And that's our vertex form. All right, I'll see you in class.